Okay, it says the function f is continuous. On this closed interval. They give us two values of f. We get two different values of f. Okay, if there is no c, okay, so right away, you do need to memorize that when you see that kind of phrasing, they're likely to be testing you on these three. One of these three, or perhaps all of them. The mean value theorem, the intermediate value theorem, and the extreme value theorem. We did have time in the year to do several problems related to mean value theorem. These other two are very easy theorems, so I just saved them for March and April. We'll just talk about them as we encounter them in different problems. So this phrasing is the phrasing that is used when a textbook describes the mean value theorem, the intermediate value theorem, and the extreme value theorem. So it says, explain why there's no c for which this f prime is 0. Okay, right there is a huge clue. They start out by talking about f. They give us values of f. They give us values of f, but they ask us about f prime. So, as in all problems, you've got to pay attention to what do they give you and what do they want. Does that make sense? Okay, so they're giving us f, but they're asking about f prime. That's mean value theorem. If they're giving you f and they're asking about f, that's one of these two. So that's a big separator. Given f, ask about f prime, that's this. Given f, ask about f, that's this one. So let's see what it says here. Reviewing the mean value theorem. The mean value theorem says that if f has a secant slope, in this case equal to 0, because look, this y-coordinate and this y-coordinate at two different x's both have a y-coordinate of 0. That means between those 2 points, the secant slope of f would be 0. So because f has a secant slope of 0, that means somewhere on f there will be a tangent slope of 0 as well. So f has a tangent slope of 0. Meaning f prime of some x coordinate must equal 0. That's the mean value theorem. But the mean value theorem is only valid if the function f is both continuous and differentiable. So we're already on guard for that kind of an idea. So which of the following statements must be true? From this x to this x, is it true that the slope of f must always be positive? Now that doesn't even make sense. Like if f has a y-coordinate of 0 and another y-coordinate of 0, f could just do that. So there's no requirement that every tangent slope on f would have to be positive, because these tangent slopes of f are definitely negative. So I know that this is not a must be true, so it's not this one. Questions from anybody? Keep going. Oh, same thing. By the same argument, my tangent slope doesn't always have to be negative. This tangent slope is positive. That one's definitely not a must be true. I know. It says for all of these values, does the tangent slope have to exist? And here's why that doesn't have to be true. The graph of f could have looked like this. They don't tell us that f is differentiable, therefore f can have a corner. And if f has a corner, there will be at least that one spot at the corner where the slope of f will not exist. That doesn't have to be true. because F could be differentiable. You don't know, but it could be.
Getting a 2 on your AP test.
So commentary from the studio audience now. So let's see. Does the derivative always exist?
I don't.
But F, no, I just showed that the derivative doesn't have to exist. Oh, I got it. I'm going to tie this back together. I'm trying to show that there's no place where the tangent slope is 0. And that's true. There is no place where the tangent slope is 0, which following sentence must be true. Those don't.
It has to be undefined somewhere.
I vote for that as well.
I cheated.